Okay, we're dealing with linear inequalities, part one. Should be on page one. It says these are called linear inequalities. Why? Linear because they're either slope-intercept, which would be this one and this one, or standard formal lines. Okay, two variables because I've got x and y, both of which are variables. Okay, so graphs of linear inequalities. They're going to involve two things, which are a shaded area and a boundary line. And the boundary line obviously is going to come from that equation right there. Okay, so let's take a look at this and talk about how to graph these things. Okay, so one thing you must remember, if, this is very important to remember, if you multiply or divide both sides by a negative number, you have to switch the inequality. Okay, so let's take a look at this guy right here, which was 2x minus 4y is less than 10. Okay, so the first thing we need to do then is to graph the line, and to do this we're going to use slope and either y-intercept or a point, depending upon which form it's written in. We're going to use solid lines for when it is greater than or equal to, and also less than or equal to. Use dashed lines or dotted lines when it's not equal to. It's just either greater than or less than. And to pick a side. So one of the best ways to pick a side, just what they're doing there, you pick some point on one side of the line to test. You plug it into the original equation. Now, you can use 0, 0, and that's a good idea to do if you can, because it makes the arithmetic very easy. And you can use 0, 0 as long as it is not on the line. The point you must choose has to be not on the line. So, if the final statement is true, you shade that area. If it's false, you shade the other side. Okay? And they worked through some examples here. As you can see, they went through, they started in standard, they subtracted their x over first, their 4x over, divided by 2, and now you've got y is greater than 2x plus 5. So you graph this. My y-intercept is a negative 5. My slope is 2, so I go up 2 over 1, and then you get that line. They have it dashed. Okay? So now we pick 0, 0, because it's not on the line, and we plug it in. So 4 times 0 minus 2 times 0, is that less than 10? We get 0 is less than 10, it's true. So the side we shade in is going to be right there. And that's how you do this. Okay, let's work through these two examples at the bottom. y equals 2x plus 3. Well, they made this one easy. Here's my y-intercept. It's at 3, which is right here. Negative 2. So I'm going to go down 2 and over 1. 2 and over 1. And since it's got an equal to, this line will be solid. All right, so there's the line. Now I pick my test point, and 0, 0 we can do. So y is 0. Is that less than or equal to negative 2 times the x value, which is 0, plus 3. All right, so what we want to know is 0 less than or equal to, 2 times 0 is 0, 3, and that's true. So we shade this side of the line. Okay, on part B, we made it a little harder, but there actually is a trick to solving these things. You've got it in standard form like this. First thing let's do is let's plug x into 0. And if you remember right, that gives you your y-intercept. So I'm going to have 2 times 0 minus 3y. And for right now, if we're doing this, we're going to set it equal to 6. That goes away. So I have negative 3y equals 6, or y equals negative 2. And there's my y-intercept. So I plot that point. Now the next easy thing to do then is to get your x-intercept, which is where y is 0. So I come back up and I put 0 in for y. So I end up with 2x is 6, or x is 3. So my x-intercept is at 3, 0. I've got 2 points. I can connect my line. And it's dashed because these are not equal to. All right, and this is actually probably a lot easier and a lot less painful than actually going through and try to get this thing into slope-intercept. So if you just plot your 2 points, you can graph this line pretty easily. All right, so now we pick our test point, and hallelujah, 0, 0 can be used because it's not on the line. So I go back in, I plug it into my original. So 2 times 0 minus 3 times 0. Is that greater than 6? So I end up 2 times 0. I got 0 is greater than 6. That is false. So what it tells me is it's not this side, but it's the other side of it I need to shade. And that's how you solve these. Okay. Let's do some practice. And then you're going to be doing the next page by yourself, next 2 pages by yourself. All right. So take a look at this one. This is already in slope-intercept form. So my y-intercept is 4, which is over here actually. Now slope is 2, go over 2, up 1. And this should be dashed because it's not equal to. Four, 6. All right, and now we pick our test point. 0, 0 works. So I check to see if 0 is bigger than 2 times 0, plus 4, or is 0 bigger than 4? This is false, which means it's not the side that that point's on, but the other one. So we graph that side right there. Okay, number 2, we're back into standard form here. I would suggest you do the same thing. So let's put 0. Let's find our y-intercept, which is where x is 0, which means this term goes away. I'm going to have negative 5y is 15, or y is negative 3. So I plot that point. There's my y-intercept. And then I go back in and I find my x-intercept, which is where y is 0. So that term goes away, and I end up with 3x 15, or x is 5, which is right there. Okay, this is less than or equal to, so this will be a solid line. And we pick our test point. 0, 0 is available. I plug it back in to this guy up here, my original equation. So I'm going to have 3 times 0 minus 5 times 0. And I want to see if that's less than or equal to 15. So 0 minus 0, 0 less than or equal to 15. This is true. So I shade the side that that point is on. Okay, number 3. 3y is greater than 12. Okay, let's solve this for y. So that will give me y is greater than negative 4. Okay, and at this point now, I can graph that line. And it's greater than or not equal to, so this is going to be dashed like this. And again, I go in and I pick 0, 0 because it's available. It's not on my line. So 3 times 0, is that bigger than negative 12? Or is 0 bigger than negative 12? And that is true. 0 is bigger than negative 12. So I shade this area up here. And then the last thing we'll do is come over here. We'll divide by 4. So x is going to be bigger than or equal to negative 4. And it's bigger than or equal to, so it's going to be solid. This line right here, vertical line. 0, 0 is available. So 4 times 0, is that greater than or equal to negative 16? Or 0 greater than or equal to negative 16? And that's true. 0 is bigger than negative 16. So I shade this side over here. Okay, now let's take a look at number 5. All right, you're actually going to have to write equations. So Jim's, Lawns R Us, charges a base fee of $20. That's going to be your y-intercept. So plus 20, plus $10 per hour. So Jim's charge, y, is going to be equal to 10x plus 20. All right. Now, Angel's charges higher fee. So for Angel, this charge is going to be bigger than Jim's. So it's going to be that. So now we can come in and we can sketch a graph looking at where Angel's pricing would be found. So we've got y-intercept of 20. I've got x slope of 10, so I go up 10, do 20 to 30 and over 1, up 10 over 1. Now this is going to be dashed. Because it's not equal to. All right, there's 0, 0, so let's check it out. Is 0 going to be bigger than plus 20? Or is 0 going to be bigger than 20? That's false. So Angel's pricing is going to be found up in this area. And this is what you will be doing on the next 2 pages.